I want to give a brief introduction for myself. So I am Hina Dikshit. I currently head AI investments at Samsung Next, and I'm also focused on metaverse and gaming investments, which includes like some aspects of Web3 and AR as well. Um, Samsung Next is basically like it's a private equity arm of Samsung, and I have invested in some very cool companies. I have invested in 4 companies in past 6 months. um, one of which is a knowledge management company. The other one is in self-supervised learning. The third company is in federated learning, and the fourth company is in intersection. It serves as a data warehouse for Web3. We have like made other investments as well. Like we invested in Board API Art Club, Axie Infinity, Ready Player Me. So there are a bunch of like, cool companies which utilize AI in some aspect in synthetic data generation or character generation. And those are also part of our portcos. Before coming to Samsung, I was part of Apple. I led a team there for around 8 years, and I led like several projects there, which include like AI, developer tools, iCloud, accounts, you name it. And basically, like I must have done some aspect of that particular feature that you're using today, even like unlocking your phone or two-factor authentication. So I was part of all these projects. I was DRI for them. And being a techie, like who isn't like excited to learn what's new out there, right? Like we always want to learn what's the hot tech right now, what is new thing out there, right? So that's why like I tend to learn as I meet like researchers and I meet like startup founders, and I think I have found a like very interesting way of like putting my notes together and sharing them with people at the same time, like whatever is shareable and it's like a public information, right? So focusing on my recent learnings, I want to share some new developments in synthetic data generation. uh, I know it's a new topic. Like in that regards, I was looking at some of your old talks. So I am okay if everyone asks questions, or like, if you have any question, like let me know. Okay, so next slide. So just to realize like how quickly the AI is advancing, let's remember like, how many parameters GPT-3 has. Like it has roughly 175 billion parameters. Now GPT-4, it is expected to have like 110 trillion parameters. So there has been a staggering increase in the size of these neural networks, and now the capacity of these neural networks and their tendency to be more creative, it knows no bound anymore. And I don't know like if you guys have seen like recent text to image neural networks, like DALI, image to text, Imogen. These are so amazing, like coming from Google AI or DeepMind or OpenAI, right? Like you can basically like type something that you want to see, like a pink elephant playing poker, and you'll start seeing like these very very graphical, like beautiful, creative, imaginary images, like created for you in minutes. Very cool, like how far AI has come in creating various like computer vision related, like images and videos at the same time. Like based on just your like one single image, a 30-second video can be created now. So AI knows no bound. And before, like even we were here, like where AI was always already making like some impressive strides. We were doing very well in voice recognition, we were doing very well in machine vision, and we see those technologies in front of us every day. Like take it, like for example Tesla, right? Like the autonomous vehicle of the FSD. Everybody is like they go wow when you are able to parallel park using just a button on the screen, right? And then we also know like about the deep fakes. Everybody has been alarmed or wowed by, oh my god, these deep fakes look so original. So the AI has actually come very far. Now for synthetic data generation also, with the demand of much more data in training these huge neural nets, which require multiple billions and trillions of parameters, the need for that amount of data has also gone exponentially high. Now this is the reason that there is a space for synthetic data generation, because bigger is the neural net, the more is the requirement for training data. And at the same time, maintaining a really huge data set is very difficult and complicated, because you don't only need the data set, you also need to able to annotate it, you need to be able to label it and manage it and find your biases in it. And that's why the real world data, it's full of biases. And the reason being, for example, a certain corner case, where a certain image looks very similar to something else, the AI can misunderstand that, and that can lead to biases. One example is Google's photos started identifying African American people as apes, which was very offensive, right? But at the same time, it happened because there was bias in their data. And in order to overcome such biases, there is a lot of research work going, but that's one strategy to do that, to counteract this, that we surface these biases. The other strategy is to use synthetic data, which is very well annotated, it's already well labeled, and that makes the performance of the AI models much more faster and much more reliable. Now moving on to what exact methods we are going to discuss today. The number one method would be, actually you'll need to go back, Sophia. Yeah, I'll tell you when to change the slides. So one slide back. I have very few slides actually, so you don't need to change slides very often. So we are going to discuss 3 techniques today, and mostly the top 2. The third one is more of a research work in progress. So I'm happy to give some idea to the community and see where they can take these ideas to. So first one is GANs variations. There are multiple GANs variation which are out there, which are used to generate synthetic data. So we'll look into 3D GANs, which is a geometry aware efficient neural network for generating synthetic data. And then there is NeRF, which is neural radiance field. The third one is we want to discuss how we can leverage federated learning in synthetic data generation. So now moving on to the first one, which is GANs variation. It's called 3D GANs. Sophia, you can move to the next slide, please. Thank you. So what is 3D GANs? So 3D GANs is basically, this is one of the research work that is being done by Professor Gordon Wheatston at Stanford. He was in Berkeley earlier. Now they're doing a collaboration with NVIDIA, and they're trying to figure out, effective ways to create 3D renderings from 2D images. So this research work was of particular interest to me because positioning of humans or inanimate objects or particular animal, it's very important when you're trying to train networks, especially if you are unable to render the side view or the the rear view of an object. It's very difficult for AI to understand that okay, it is the same object. So you need to be able to train your AI model to detect an object or a person from every angle and understand those positioning very differently. And that's why the 3D rendering is very important. One such very interesting method is 3D GANs. And if we were to kind of understand this, there are several issues when it comes to rendering using the existing techniques, as they're either compute intensive, or they make such geometrical approximation which are not consistent with the 3D view, and they result in a very morphed results. I don't know if you guys have tried Reface or some of the other apps out there which automatically merge your face into your favorite character. And then I don't know if you've seen end results, but sometimes like when when the your character moves, the eye might like pop out, or your face symmetry might like look really different and unbelievable and unrealistic. So 3D GANs, this particular technique basically focuses on getting that right. And it is very important because like for training autonomous vehicle, if somebody is crossing the road, you want to identify quickly that, okay, like this is with precision, this is a human being and we are this much far away from it. So we should brake now. Right. So that's why the 3D rendering is extremely important. Now, what is going on with 3D rendering is like commercializing it is extremely compute intensive, as I was saying earlier. And plus, like whatever rendering is generated, it's of very poor quality and low resolution. So moving on to Professor Gordon Wheatstein's theory and his research work. So they want to use unsupervised learning in generating these high quality multi-view consistent images and 3D shapes. And they only want to use they want to focus on 2D image sets. So that's their data set, that they take a lot of 2D images, and then what they do, they want to be able to create a 3D rendering out of these 2D images. Now existing 3D GANs, they're very very compute extensive, and then again their quality is very very limited. So generating such 3D consistent views from these images, the shape quality will be absolutely morphed. Now this particular technique, what it does, it not only improves your computation efficiency, but image quality is also improved, and it does not rely much on approximations. And that's why whenever somebody is moving their faces, or even if you turn an object 360-degree, you'll still see a very consistent real looking view. And this technique is not only useful for the metaverse, it's also used in synthetic data generation, because it's very difficult to and time consuming to capture real world objects or real world human person from all angles, right, to able to train your data. Now how they are doing it, we can move to the next slide, Sophia. Thank you. So now how they want to do this, they basically want to produce these high quality 3D generation using a two-dimensional GANs. So they want to use any 2D GAN, and style GAN 2 is one of them, which has been proven very efficient and effective at the same time. It decouples feature generation, and it also it decouples feature generation from neural rendering itself. So it's very easy to use style GAN 2 with any particular object or animal, or say human being, right? So moving on to the next slide, Sophia. Yeah, so this is how the neural architecture looks like. In this, you can see what they are doing is they are trying to get a mapping network, and they have around 512 scalars for that. Now they are using the same similar StyleGAN2 generator, and they kind of current resolution of these images is 256 by 256, and they want to use a triplane representation of those images. And then using the reshaping of the features, they want to use a neural renderer, which uses a neural network based volume rendering, and it also uses a triplane decoder. Now what they do, they want to take the raw image that gets as an output, and kind of uh, increase the resolution of it using a super resolution neural network. Now in the end, they are using a typical style GAN2 discriminator, which is an essential part of GAN's framework, and they are trying to get the end result out there. Now it's even if we kind of want to train with a simple GAN, the rendering is pretty expensive. So it's very important to use this hybrid explicit and implicit 3D representation. in order to kind of like make that neural rendering as efficient as possible. Now, this particular representation, it combines like the explicit backbones, which produces like, features aligned on three of these, orthogonal planes with a small like implicit decoder. Now comparing it to a typical like multiple like a multi-layer like perceptron representation, the 3D representation is more than like, I think 7 to 8 times faster. And it is like, it not only is faster, but it uses like less than one of like 1/16th of the memory of a normal like traditional GAN out there. So while even if we are using like say StyleGAN 2, like we are able to like, create some or like preserve some of the properties of StyleGAN, which is like, the representation of the latent space, but we are still able to get, much more effective results when compared to like, not any other 3D rendering, like, GAN's algorithm out there. So moving on to the next slide. So here, so this is the end result. Uh, if we can like, do next, I think like I put a video there. I'm not able to see it somehow. So I try to put a video here, but usually as you can see, like, all these images like are generated just based on 2D images, and you can see like they have intense 3D depth mapping, and each and every feature of each and every object or human being is very well laid out. Like you can see a wrinkle, you can see like, perfect like, the like wrinkle around the eye, you can see their dimples, each and every like, the super resolution does wonders here, and it's able to bring out the features and properties of these in like, these humans and animals like very well, unlike any other GANs algorithm out there. So moving to the next slide, Sophia. So yeah, so here like, and you'll need to press it once more. Yeah, and you'll need to stop. I think you'll need to press once more. Yeah. So I think if we go back, I was hoping the video would play, but somehow like it's not playing. But it kind of like shows you how in depth, like, it looks very real, and the 3D depth mapping is so precise. Now moving on to NeRF. And what is NeRF? NeRF is basically neural radiance field. This this is a very unique way that I recently learned about. I was in a conference at Stanford where they brought out this really interesting research work, and I was like, oh my god, this is superbly mind-blowing. um, so NeRF is nothing. It's simply like a fully connected neural network. And what it does, it can basically like generate novel views, or like your 360 views, just by using like set of 2D images. And all it needs to generate like your these 3D scenes is like a 5-dimensional coordinate, which is nothing but your latent like your spatial position, your 3D coordinates XYZ. And then you just need like a viewing direction, which is like which is kind of like very important, of course. Like from this view, this is the angle and this is the light intensity. So you just need these this 5D input, and you are good to go. And you are able to generate these like highly vivid 3D scenes out of them. So I think we can move to the next slide. Yeah. So here, like, can you try like seeing if the videos will play by doing next? Because I put videos here and I just want to
go next slide.
Yeah. Because I think the videos should start playing. Yeah. I think no. Just go back. Go back. Yeah, and one more back.
Hold on.
And one more time. Yeah, and now like move forward just once. So I think like probably the video is slow or something, but this entire 3D scene. So it's a three-dimensional like video, and this entire scene like gets generated just by one 2D single image, and it has like breadth and depth of like a 3D, which is like pretty amazing when it comes to rendering. Now what is nerve, like so as I was telling you, it is a fully connected neural network. It's you can think of it like as highly effective way to generate like 3D renderings of any space out there, creating a scene like, and we need those kind of like technology, especially when you're trying to train autonomous vehicle or robots, or like say like even any any other AI model out there. You want the AI model to not only see a 2D image, you want it to understand the depth of the scene as well. Depth, like how deep is uh, that particular like object from my periphery, right? Like you want it to understand that depth as well, and that's why like having this kind of technology is very very helpful. So as I was telling you earlier that basically nerf uses a 5-dimensional input, and what it does, it basically it is trained to map directly from the viewing direction and the spatial location to opacity and color. Now using volume rendering to render these new views, nerf can actually be very very compute, I think it's very compute intensive in that regards, in processing these complex scenes, and it can take actually hours or days, which is like still a lot, right? Like because nowadays you can see like how quickly this can work. Like AI models usually give you output within like few hours, but nerf actually takes like multiple days, it depending upon what kind of data it has. However, there are like certain new algorithms which are trying to help and dramatically like improve these like performance issues. And I want to like kind of like dive a little bit into how some of the terminology that I'm going to use. For example, like I want to explain what do I mean by rendering when I say like 3D rendering. So rendering is nothing but it's a process of creating an image like from a 3D model, and the model will contain like various features like your textures. It can contain like your shading or shadows, or it can have your lighting, various viewpoints. And then the role of rendering engine is to process these features and to create like a realistic image. Now volume rendering, like what it does, it basically enables you to create a 2D projection of a 3D discretely sampled data set. So view synthesis is very important, and you need to be able to understand that it is completely like opposite of volume rendering. What it does, it basically involves a 3D view from a series of 2D images, and that's what nerf is focused on, right? So it is focused on view synthesis. So when I say it synthesizes complex views or synthesizes novel views from complex scenes, it's basically means that we're taking like 2D images and then we are trying to create a 3D view. Now nerf, like it uses power set of these input views and to optimize like a continuous volumetric scene function. We can move to the I think like here, yeah, I think it's, yeah, let's use this one. Yeah, so in general, I think you can think of this from a perspective that a continuous scene is like basically a 5D vector valued function, and it has like some characteristics. It can have like 3D location and your viewing direction, and the output is going to be color and volume density. Like you can think of it as like from that particular viewing direction, how much volume it has to render, it has to understand that, and the emitted color will like signify the lighting, the shadows and shading, and all those things that I was talking about earlier. Now nerf, like this can be used to generate like sample set of 3D points. You can like, use it by matching camera rays throughout the scene. It can also be used for producing an output set of densities and colors. Like, you can input some sample points with their corresponding 2D viewing directions, and you can use that in your neural network. It can also like accumulate various densities and colors into a 2D image. By using like, these classical volume rendering techniques, you need to combine like NeRF with these volume rendering techniques basically to obtain that. Now, original NeRF, as I was telling you, that it is pretty compute intensive and it is very slow to train and render, and it can only handle like static scenes. So if you have like a moving video and if you want to generate something like a 3D rendering out of that or do volume rendering using that, it is not possible using NeRF. So because there are these like, issues with NeRF, like, there are certain other techniques that are used in like, in sync with NeRF that can like, overcome all these problems. And neural sparse voxel fields is one of them. What it does, it basically, it's a neural scene representation that enables fast and high quality rendering that is not dependent on a specific viewpoint. So it works by defining the voxel bounded implicit fields organized in sparse networks of cells and progressively learns the voxel structures in each cell of that particular network. And then there are a bunch of other techniques which I can go on about, but I think it's a very cool area for you to look up. Whoever is interested, please feel free to reach out. I'm happy to point you to these specific techniques. I'm also going to write a small blog about this in my website, which is hinadikshit.com, and maybe you can go and like, check it out there. Now moving on to the next topic, which is federated learning in synthetic data generation. So I didn't make like any slide for that, but because I wanted to keep it as an open topic for discussion with the audience, and I wanted to see like some research work or like get some pointers from you guys. I'm trying to do like, research myself in this space, but I think this is one of the upcoming areas, and I can think of it from this perspective that like any synthetic data generation obviously requires some sort of input, right? Like, so you will need to take like pictures, or you will need to use image data sets to use these particular techniques, right? Like, so how can we use, privacy efficient techniques to do this? And federated learning is one very growing and vast field, I think, in this space. And we can also apply it on synthetic data generation as well. So what is federated learning? Very simple. Like, it basically like, make sure that you are able to train your AI models without like on various like nodes or data points or various like, endpoints, without letting them share data with each other. And there is one aggregator in the center, which serves as an aggregation server. And what it does, it based on like, various time bound triggers or some other triggers, it basically orchestrates these learning rounds. So it sends like the pieces of the model. It can either send pieces of the model using split-NN kind of technology or like architecture, or like federated learning goes like beyond split-NN, where it kind of like sends the model out to each of these nodes, and then the model these nodes, they basically train these models locally, and they send the models back based on like in that particular like local node, whatever like was the best performance for that particular model gets sent back. And then the central aggregation server like, averages all these models out and sends these models like, back to these particular nodes, which can again start the training process. Eventually the end result is an averaged out like, AI model, which like kind of like works efficiently around all these nodes. Obviously there will be some outlying like, defaulters which will not achieve as much as or like as much efficiency as others. There would be a lack of personalization in this technique, but there are a bunch of other, like, methods out there, and which also includes like lottery ticket hypothesis based federated learning, which is a very interesting research paper that I came across recently. So that, what it does, it basically like makes sure that the personalization is secured for these end nodes and still be able to like get highly like performing model in the end. So we can use like federated learning for synthetic data generation as well. So pretty interesting space. I'm looking forward to like some you know points from all of you, and happy to discuss this. So
I
yeah.
have one question, like why it's important to apply the privacy related sort of techniques to synthetic data?
Yeah, I think because whatever synthetic data is generated, like it's generated based on real data, you cannot train your AI models to generate like synthetic data without it understanding or knowing like what it needs to generate. So there has to be a reference point, right, to do something. And that's why like real images are used, or real like data sets are used in order to train an AI model to generate these synthetic data sets. So we don't want to continue doing that, and like because it's not privacy friendly, and because like for example like it's you might be sharing like people that you have who have agreed upon, right? But a lot of time like these data set companies, they might be getting their data which might be like private, and they still want to like create synthetic data out of those data sets, but at the same time it's very like it's not privacy friendly. So you want to make sure that they can help you train your AI model without sharing their data. And that's why federated learning can play like an important role here, because these companies, like even though they have like really important data, but they don't need to expose that data to anybody, and end result will also not expose your data to third party or any other person, right? So it's much more.
I have a practical example of this problem. So if
Sure.
you think, because I worked in a geophysical, in a very big geophysical service company, if you think that you want to generate synthetic log well data, and typical well logs are used to discover hydrocarbons in the subsurface. So companies operating in that environment are very they want to keep their data very secret. So even if you use well log data for training a system for generating synthetic well log data, the synthetically generated well log data could reflect the actual data. And so the companies that wanted to hide maybe their discoveries with the well log data, maybe they want to keep even the synthetically generated data secret for not exposing this kind of data. This is what I have in mind for the problem of security that Hina was mentioning. It's an example, let me say.
Yeah.
I have a question regarding the synthetic data generation. Simplifying a bit, but I don't know if it's simpler. So you are talking about 3D rendering. I would like to understand if it is possible to apply synthetic data generation to time series simulation. So
Yeah, I think some companies are doing that. I think Hazy is focused on actually financial data, but there are certain companies which are trying to focus on time series data as well, but it is much harder to like generate, I guess. So I haven't seen a lot of startups or any like like there is a lot of research work, but I haven't seen any company doing this or any startup doing this.
Okay, because the problem that I see in doing that, and actually while when you have an image, for example, let's simplify. If you have a 2D image, you have to create a synthetic face of people, of some people. You have a sort of limited range for the values of each pixel of your image. So you know upfront that once you have trained your network,
Yeah.
in the end the values stay within a certain range. but with a time series that potentially has, for example, we can talk about financial data, but also, I don't know, the CPU consumption of a machine. So you monitor the evolution of a certain measurement. So this time series can have a trend, okay? So you are not sure that if you have trained your neural network with some initial data that have a trend, you're not sure that this neural network will be able to produce, for example, time series that go out of the range that you provided during the training. And this is still a big problem that honestly, I also have not seen anyone being able to do that yet.
I think the only company that I can possibly think of is Ali's Gretel, which might have something like going on, but I'm not too sure. I'm meeting Ali like sometime later, but I know Gretel is doing some amazing work in synthetic data generation. So my guess would be they might have something for this kind of like, problem. But other than that, I have not seen like, too much happening in time series synthetic data generation. Most of it is actually focused on CVML.
Maybe
Thanks.
we can give opportunity to others ask questions. I see like Iman has question. Hina, when you were talking about 3D GANs, so question is, do they generalize to non-human animal objects?
Yeah. So they kind of like can also do inanimate objects or non-human objects as well. Yeah.
Mm-hmm.
But is it the case that those objects have to be in the training set of the model?
Yeah.
Like
They have to be.
they can't really generate very new objects.
Yeah. If you want to generate new objects, then yeah, you will need to like go beyond what 3D GANs can do.
Right.
Mm-hmm.
Yeah.
So the question: does the level quality of lighting in the 2D images matter?
I think it does, because you want to eventually get like, it does, because you should have all the variations, right? Like you should have like less lighting, low lighting, high lighting, right? Like, because I don't think like the 3D rendering would be able to kind of like figure out the like, lower lighting or higher lighting, that kind of like parametric. It could like do the shadows and lighting from various angles on its own, but it cannot like quickly convert a particular scene or like, animal or human being in and show it to you in various lighting. So I think probably that is something that for which like you'll need some other algorithm to kind of like on top of the same algorithm, right?
Mm-hmm. I think
Maybe
Neeraj
like add some variation to it. Like you can probably add a variation, I think. Yeah.
I think Neeraj asked a question. Neeraj, is it about federated learning? How to prevent identifying features from leaking into synthetic data? Hold on. Yeah, leaking into synthetic data generated on the edge.
Yeah, I'm not aware of this, honestly, but this is a very interesting question. But I'll look at it and I'll let you know.
Yeah, I mean, it's a very new field, right? Like first time, actually, Neeraj was working on federated learning. He actually built a framework for healthcare, where
Okay.
they collected patients' data from their phones. This is first time like I personally hear about applying federated learning to synthetic data.
Yeah. I think I haven't like really seen any research work in this aspect, but I can figure out like obviously there can be some way that like, your identified features or some like existing data might be not able to like anonymize that or generalize that, right? Like using federated learning. But for that, like you'll need some additional algorithm. It cannot be just simple federated learning, but you can use some other variation of federated learning to do that, I guess.
Yeah.
Take care of it. Yeah.
I see a question from Edward. Edward, do you want to unmute yourself and ask?
Yes, I've seen a similar deepfake situation where a woman in Asia was creating a career as an influencer. Unfortunately, she was using filters on her videos to make herself much more attractive. Until one time, the filters failed; they collapsed while she was online. And so, to me, this seems to be a much more complicated problem. She was in motion at the time.
Yeah.
So it doesn't seem like she could do it offline. But how did she manage this in terms of the mathematics? I mean, is there were they using in terms of how can the filters be so efficient in processing?
There is an entire research paper on this, Edward, like that I will share with you later. It's a very interesting like research work that I came across. So I'll be sharing that later with you. It's a must read. Like this is something that like I was very curious of as well. But yeah, happy to share that.
Thank you.
So the problem was, Edward, like how technically that problem could be solved in real time. Like, so basically, what in terms of research, what advancement should be done, like in order to avoid this kind of situations?
Yes. The reason I'm a mathematician, so I'm coming at it from a different viewpoint, and I used to work in a kind of like the opposite problem. I used to make chemometrics matrix, P matrix, projection matrices from highly collinear data. They were concentration curves, and we would reduce this data down to a single vector, so that you take this group of data, you apply it against this matrix, and then you get out a vector of concentrations. But the method of creating the matrix was very sensitive. If you use the wrong package, the matrix is ill-conditioned, and your data you'd crash your computer. It was just very bad. So I'm looking at here, it's kind of like the opposite condition. You're taking very sparse data, and then you're creating a 5D vector from a 2D image, and then creating a 3D image from it. So I was wondering just basically how you do the math. What packages do you use to prevent ill conditioning? Because I have seen some reconstructions of 3D, and they've been pretty awful. The head turns, and it's like a gaping hole, and that's, of course, it's drawing on zeros.
Yeah, I will share like a detailed paper. They probably even have paper like I think it was in Papers with Code. So they might have some code repo as well. They might have like details about it. I'll share it.
Do you know, like, if you know someone who is like working on this kind of problem, maybe they could give a talk, right?
Sure.
And like tackle this specific problem, because
Yeah,
I think
I can tell you like exactly the research paper that I read, and maybe you can reach out to them and ask them that if they want to do a talk on this.
Yeah, I think it's a really cool topic, and we will try to find someone who is like doing this research, and we can like cover this.
Sure.
Shashank, do you want to ask your question? I see your.
Hey, Sophia. Can you guys hear me?
Yeah.
Hey, Hina. Hello. Hi, Sophia. So my question is that we haven't seen much development in text to 3D. That is something like DALL-E, but for 3D, in the sense you put in a text description and you get like 3D rendered model.
Yeah.
Do you see much value in this idea, especially in like gaming, movie production?
I think so, especially in metaverse, right? Like I recently gave a talk where I emphasized on generating like, 3D, like, kind of gaming experience. I was talking about an experience. So I went to drive like a Ferrari for 5 laps in Speed Vegas or something, like, there was a like cool joint there, and I went there and I took these laps. But I always wanted to share this memory and like share this with my brother, and he's in India, so I couldn't, right? So I wish I could do something like that. Hey, I can share some of my 2D these 2D videos and images, and create like a AR sort of experience, gaming experience, where we both can create our avatars and take these labs together, or like, create quick games out of it. So yeah, so I do see like, some application. Obviously this will require a lot of stitching and you'll need to like, use multiple algorithms to make this happen, but it's not like far, like in few years we will get there. So definitely see like a lot of like value in this. The other thing is, there's another company called Vimmers. It's very interesting. What they're trying to do is they want to create these 3D like videos using 2D videos, so that you can like explore, you can like explore them in your VR set, and you can like move around and feel that you're part of that particular event if you missed out on it.
Yeah, Vimas is doing some really cool stuff. So what I am talking about specifically is revolutionizing the whole pipeline of graphics itself. For example, when you build a movie on Deadpool, say, or like Iron Man, you build like a whole model of Iron Man, very detailed, and you rig them in animation software. So something like, okay, if I type in a man wearing a hat and leather jacket, and what you get is like not like a full model, but say 60% of the work is done by AI. And then you can just download that 3D model in Blender, Maya, any 3D editing software, like just do touch-ups on that. So to like reduce the time of model making in gaming, or like avatar making in gaming or movie production.
I think that's cool too. That's a very good idea. Okay.
And actually, so if in case you like it, I do have a demo on my website. So I'm a hacker engineer based in Bay Area. So it's called neural3d.xyz. It's a website. It's free, completely free. You can just like go and like try it out.
Are you on Bugout Slack?
Sorry?
Are you on Bugout Slack? Hold on.
I am. Yeah, I am.
Yeah. So
that's how I figured you guys.
Yeah, we have share your project channel. You can actually share the link there.
Oh yeah, sure. Yeah, thanks a lot. Yeah,
and then there is a very cool company called Kaidim, which is also focused on these 3D renderings. I think they are the only companies that I've seen like doing pretty well in this space. You should check them out. Like Constantina, she's I can say like she's a friend of mine now, and she's amazing, very kick-ass. Like she kind of is focused on some of very cool, interesting, like ideas about this. You might find it interesting, and you might want to like chat with her sometime.
Yeah, sure. What's the name of the company? Could you just?
It's called Kaidim. I'll just put this on the chat.
Yeah, in the chat. Yeah. Okay. Sure, that would be really helpful. Yeah, thanks a lot, Hina. Thanks a lot, Sophia. Nice talking to you guys.
Yeah, likewise.
Okay, I see a question from Edward. Has there been an attempt to create a symmetry detection method? For example, if a face is determined to be bilaterally symmetric, then creating the other half can be computationally easier?
I'm not aware of this. I'm so sorry. Yeah, I haven't ever looked at this, because I never thought of it as being relevant for us as as a startup to look at, or like I never got a chance to work on this feature even when I was at Apple.
Actually, I'm wondering, Hina, I mean, you are also doing investments in Web3. I'm wondering from like investor perspective, how do you evaluate Web3 projects? Because the field is Web3 is so different from like sort of traditional SaaS, right? Yeah. What are there like metrics, how you evaluate projects?
I think it's still the same for us. Like we want to understand the space very well. So at least like we invested a lot of time in just doing that. Like my past 6 months were just theorizing the thesis for my investment rationale. And I think like after you know that space that you are going to invest in very well, you know, okay, these are the problem spaces which are yet to be filled, and I'm looking for a good startup to come and fill this particular like, you know, stack to address a particular problem. Once you do that, you kind of like are able to, you know, track those startups. The original idea stays the same. They have to like solve a valid consumer pain point, and then they need to have like, you know, a valid solution, a working solution that can be commercialized. The third thing that is important is that they need to like, you know, kind of like have some differentiation than any other company out there, because a lot of companies might be trying to do the same thing. So that is one
the
other,
edge.
yeah.
The edge, either it's like a team or like something like really working.
Yeah, exactly. Or like
Okay.
previous experience, or it could be just product market fit. There has to be that like differentiation or that edge.
Okay, cool.